This is the AB 5.3 review. Calculators are allowed, and it's number 7. So calculators are going to be used quite a bit in this one, so it'll probably take a while, but you might only need to watch part A. So a rectangle with one side on the x-axis has its upper vertices on the graphs as shown in the figure below, and the question is, what is the minimum area of the shaded region? So in order to find minimum values, we need to be able to take the derivative and find the critical points by setting that derivative equal to 0 or undefined. And before we can do that, we have to know what it is we're trying to minimize so that we can set that up as an expression involving x and then take its derivative. So the first thing we're going to do is we're going to write the area in terms of x. And we want the shaded region. So we can see that the shaded region will be the entire region minus the rectangle. So we've got to be able to write all of that in terms of x. So the first thing we're going to do, just like we did in our optimization section, is we're going to label this distance as x. Remember, we went from the origin horizontally to the right to one of the edges of whatever shape we're dealing with. When we do that, that enables us to label this point here, and we can start getting the dimensions. So this will be x comma sine of x. And using the symmetry, we can see that this is x, and we know that sine intersects the x-axis at pi. So this distance right here, or the base of the rectangle, will be 1 pi minus 2 of those x's. And the height, you can see, is going to be this y-coordinate, which is sine of x. So the area of the shaded region will be the accumulated area underneath the sine curve, which is the integral from 0 to pi of sine, minus the area of the rectangle, which is a sine of x, which is the height, times a pi minus 2x, which is the width. Now we want to be able to take the derivative of this and then find out when it changes from negative to positive, and then once we find that location, we need to plug it into the area function in order to answer the question. So that means we probably want to put this in y1, and we want to put y2 to be the derivative of y1. So one thing you need to know about your calculators is that you can't put definite integrals into the y-editor. For some reason, that causes a problem. So what you want to do instead is compute this first on your home screen and then store that number in. So if we look here at the calculator, let me zoom here for a sec. If we look at the calculator, we can see that I have computed that accumulation, and it is 2. So I know that I need to put the 2 minus this expression in for my y-editor. So I'm going to go to y equals, and I'll do 2 minus the sine of x times a pi minus 2x. So double check that it looks like it's supposed to. We have a 2 minus a sine of x times an x minus a 2x. Now y2 is going to be my derivative. So I can do second derivative of y1 of x with respect to x and hit enter. So now I've got my y2. Now I'm interested in knowing when this function, when the derivative function equals 0 and changes from negative to positive. So I'm going to graph just y2. So I'll arrow up to y1 and turn it off using F4. And then I'm going to set my window. If we go back to my picture, I know the biggest that x can get is a pi over 2 before I run out of rectangle, because that means this x is going to be coming toward the center at the same time. So I will go to my window, and I'm going to look from 0 to pi over 2 for my x's, and then for my y's, I just need to see when I cross the x-axis. So I'm going to go from, say, -1 to 1. Once I've set my window, then I will graph by doing diamond F3, and I'm going to watch to see when that graph of the derivative crosses the x-axis. And we see that it's happening right here, and it's changing from a negative y value to a positive y value. So the derivative is going to generate a 0, which corresponds to a minimum on the original function. So to figure out what that minimum is, I need to first find the 0. So I need to be to the left, and then I need to be to the right. And I see that my location of the minimum occurs when x is 0.71046, etc., etc. Now notice that it's stored in the calculator as xc, and the question is asking what's the minimum area. So to find the minimum area, I need to plug that xc into the area function, which we put in y1. So we'll go to the home screen and we'll do y1 of x alpha c and hit enter, and we can see that the area at that value is 0.877807, it looks like. So there's our answer, and we're done with part A. Part B works the same way, except that we have the rectangle is centered on the y-axis. So this time when I label my x as the distance from the origin to the edge, up here I will have x comma cosine of x over 2, and I can see that my area in this case is going to be the accumulation of that cosine of x over 2, and we'll get to the limits in a second, minus the area of the rectangle. So the area of the rectangle in this case will have a height of cosine of x over 2, but it will have a width of 2 x's. So now I again will let y2 be my derivative of that, and I'll let this be my y1, and I can see that I will run out of rectangle at the same place that I'm going to have my upper limit. So let's figure out upper limits of this. We know that cosine equals 0 at pi over 2 and at negative pi over 2. So that means this is going to occur when the inside of the cosine, which is x over 2, equals plus or minus pi over 2. If I want to solve for x, I would need to multiply by 2, and I would cancel with this 2 and end up with positive pi or negative pi. So I get a negative pi and a positive pi. Now my job is to figure out excuse me, what this definite integral is before I try to put it in my y editor, because if I put it in my y editor, it's not going to work. So let's do this. We'll pull the calculator over. I need to integrate the cosine of x over 2 with respect to x from negative pi to positive pi. Oops, I guess my integrate didn't hit. So we'll integrate that, sorry. So we end up with a 4. So now I'm going to go to my y editor, and I'm going to put in my 4 minus the cosine of x over 2 times the 2x. Double check that it looks like it's supposed to. Boy, sorry, let me try this. That looks a little better. And again, I want to look for when that y2 is going to generate a minimum. So that means I need to graph y2. So I'll come up, turn this off. I will change my window because I need to go from 0 to pi this time. And I again am interested only in when it crosses the x-axis, so I'll just look from -1 to 1. If I graph now, and I wait for that y2, I'm looking for where the graph comes from below to above. Okay, we see that the x-intercept occurs here, so I can go find it. Doing an F5, look for the 0. We're on the lower already. We move to the right, now we're on the upper. Again, we have a location of a minimum, which is at 1.7206672, and now we need to find out what the area is going to be at that value, because I want the minimum area. So it's stored as xc. I can go back to my home screen, and I can do y1 of x alpha c. That means my minimum area is 1.75561, and we're done.